We've all heard it, right? It is literally the most famous and probably the most dangerous phrase in all of software development. It works on my machine. It's the ultimate developer safety blanket. You see, when you're writing code on your laptop, you're operating on what we call the happy path. The database is totally empty, the network is instantaneous, and the user, which, let's face it, is just you, behaves exactly as expected. Everything is perfectly controlled and predictable. But here's the reality check that completely shatters that comfortable little illusion. The critical question isn't whether it runs on your highly optimized laptop. The real question is, but will it work in production? Asking this single, incredibly important question is what defines the massive leap from simply writing lines of code to actually engineering resilient software systems. Welcome to this explainer. Today, we're diving deep into the core theme of evolving from a simple coder into a fully mature, resilient software engineer. We're going to break down the fundamental differences in how these two roles think, act, and deliver, pulling insights directly from our source material on the engineer's mindset. Here is our roadmap for today. 1. The core mindset shift. 2. Surviving production reality. 3. The full software lifecycle. And finally, 4. Making the engineering leap. Let's get right into it. Section 1. The core mindset shift. Coder versus engineer. Let's define the fundamental difference between these two approaches. Now, the difference we're talking about today, it's not about intelligence. It's absolutely not about your job title, and it really doesn't matter if you're writing Python, Java, or C++. It is entirely about how you view the scope of the problem. You see, a coder focuses on making the code work, and sure, that's the baseline. But an engineer focuses on making the system work. And not just work once, but work reliably, maintainably, observably, and at scale. So it all comes down to how you define being done. A coder might say, hey, I finished the task. The code runs. But an engineer asks, wait, did we actually solve the real problem? Now, don't get me wrong, coding is absolutely a necessary step. But if you stop at coding, you're limiting your impact to just writing instructions for a computer. Engineering, on the other hand, means designing solutions for real-world constraints. An engineer considers performance, security, user experience, and the actual business impact. Moving on to Section 2, Surviving Production Reality. The reality check. Because, as we just established, your laptop is a safe, cozy little environment. But the real world is absolute chaos. Just take a look at this list of production realities. The second your code leaves your machine, it hits a massive wall of variables. Suddenly, you're dealing with real users doing totally unexpected things. You've got network latency, sudden database load spikes, and third-party API failures. You're dealing with device differences, stricter security rules, missing service account permissions, the whole shebang. A coder sees local success and says, done. An engineer sees local success and immediately asks, okay, what assumptions made this work locally, and are those assumptions actually true in this chaotic production environment? Let's ground this a bit. Imagine you're building a payment button. The coder solution is pretty straightforward. User clicks pay, the front end calls the API calls the payment provider. Success, right? But the engineer knows that user might impatiently mash that button twice, or the API might time out. So the engineer designs for item potency keys to prevent duplicate charges. They actively handle timeouts, safely ignore duplicate callbacks, and build in pending states. The coder just built an action. The engineer built a reliable, bulletproof flow. Or let's look at a physical example, like an IoT water vending machine out in the wild. A coder gets the device to connect to MQTT and successfully show as online on a dashboard. But an engineer knows this thing is sitting outside in the elements. What happens if a backhoe accidentally cuts the power line? How does the device recover? How do we detect a stale status if the device drops offline without any warning? Systems absolutely must be designed to survive disconnects, firmware changes, and the completely unpredictable physical world. And a massive part of surviving production is observability. A coder might say, well, no error appeared during testing, so we're good. But an engineer just assumes things will break. They ask, when this inevitably fails in production, what logs, metrics, traces, and alerts will actually help us debug it at 3 a.m. when we're only half awake? Because without observability, your team is completely blind. You're literally just guessing the second the system strays from that happy path. All right, Section 3, the full software lifecycle, beyond the code. Let's see how this mindset expands your horizon. Look at the contrast in how we fix things. When a system breaks, a coder often debugs by guessing. Maybe it's the back end, let me just restart the server. And hey, that might work occasionally. But an engineer acts more like a detective. They form hypotheses, collect actual evidence from logs, and track down the real root cause. If an API is slow, they don't just blindly throw more server resources at it, they check for things like N+1 database queries. They fix the causes, not just the symptoms. This absolutely applies to delivery too. A coder delivers code, they add the export button and call it a day. But an engineer? An engineer delivers an outcome. They ensure the feature handles large datasets without timing out. They include necessary permission checks, make sure it's safely deployed, and always have a clear rollback plan. A feature is only truly finished when it solves the user's problem and is entirely safe to release. Even communication shifts dramatically. A coder often just reports activity. I'm working on the payment task. Which, let's be honest, doesn't really help anyone. An engineer communicates to empower the whole team. They'll say something like, status is complete, the remaining risk is delayed callback handling, and we need a decision on adding a pending state. See the difference? They highlight risks and blockers so the team can actually make informed decisions. And honestly, it really all comes down to ownership. A coder finishes their ticket and says, yep, my part is done. An engineer asks, is the whole flow actually working? True ownership means taking full responsibility for the final outcome. It means closing the loop to ensure QA knows exactly what to test, support has the documentation they need, and the feature actually works correctly after deployment. Which brings us to our final act. Section 4, Making the Engineering Leap. Actionable steps. Let's talk about how to transition into a mature engineer. So let's look at this visual cheat sheet summarizing the entire journey. Look at how the focus shifts across the board here. In local testing, you move from it works on my machine to it works in production. In reliability, you shift from just building the happy path to actively designing for failure scenarios. Maintainability goes from simply running code to writing code that is understandable and easily changeable. Debugging moves from pure guesswork to investigating root causes. And delivery, it moves from just finishing a ticket to truly owning the outcome. It's a complete evolution from naive assumptions to robust, production-level thinking. If you actually want to make this leap, here is your concrete takeaway checklist. Step 1, stop saying it works and start saying it works under these specific conditions with these remaining risks. Step 2, think way beyond the happy path. Anticipate bad data and slow networks. Step 3, add observability so you aren't flying blind out there. Step 4, learn the basics of system design, like knowing exactly when to use queues or caching. And Step 5, understand the business impact. Know who uses your feature and what actually happens if it fails. These procedural steps literally expand your career impact from just checking off tasks to owning real, tangible business results. I want to leave you with this final summarizing thought. The difference we've been talking about today isn't about writing more complicated code. In fact, the best engineers actually make systems simpler. The difference is entirely in the mindset. A coder asks, does it work? But an engineer asks, will it keep working? Keep that question at the top of your mind the next time you open a pull request. Thanks for joining me on this explainer, and I really hope this helps you rethink how you approach your next system design.